Class B, assume that that's Class A, and now is
Class Echo, actually, not Class A.
okay, Class Echo, and then now okay, here the first circle, the bottom is 8,000, and then if you move further inside, and then the old one, yes, thank you, the old one is 8,000, and the current one is 6,000, and if you move further inside the third circle, so that's the problematic area. So that area is South Los Altos. It is on the border of 85. So that line is very close to Highway 85. So if you look at this closely, and then that green line represented surfer. So that's everyone knows, right? So, and then when you compare the old L space to the proposed space, so you can see that the bottom of this surfer line is lowered by 2,000 feet. So I don't know why that is happening. Yeah, if you are saying that, okay, this is for cleaner plane or the more descent rate, and then why is that? So well, it seems to me that in order to capture the surfer flight, you don't have to make, especially that, the third circle. Yeah, you don't have to do that. So the old circle, yeah, that red thing can capture that already. Because when surfer hits that spot, it's already higher than 6,000. So it is completely unnecessary to put that third circle over there.
Okay.
And I think you can keep the old one through from the mountain, the old.
Right. Because the border used to be at the mountains, right? And now it's moved all the way to Sunnyvale.
It's not necessary to take out a little bit tail for them.
Okay. So the reason you're not seeing them descend below 4,000 out here right now is because air traffic is artificially interrupting the descent. So when they interrupt the descent, it's a stair-step pattern. Thrust needs to come up. Depending on the configuration of the airplane, drag devices need to be deployed. This right here represents the eddy waypoint on the surfer arrival. The airplane is obligated to remain at or above 6 until the eddy waypoint right here. Then after the eddy waypoint, it would do a continuous descent down to 4,000 feet. There's no way we can slant, if you will, the altitudes in a continuous descent. We need to use blocks of airspace to capture the continuous descent. So while this looks like a stair-step maneuver, it's a stair-step maneuver to capture the continuous descent. So the airplane out here would cross eddy at or above 6,000 feet. Right here, even though it's a 4,000 foot floor, it would continue to descend at about a 200 nautical mile, or 290 foot per nautical mile descent to 4,000 feet. So the airplane really won't get to 4,000 feet until about here. But this allows for the airplane to descend to 6 and 4 while staying inside a Class Bravo airspace. Just because the Class Bravo airspace out here is at 4,000 feet does not mean that the surfer arrival will be out here at 4,000 feet. It'll be out here at or above 6,000 feet, descending at roughly 290 foot per nautical mile to 4,000 feet. Physics plays in a big thing here, folks. There's no way I can take an airplane to 6,000 feet here and immediately dump it down to 4,000 feet in 2 miles.
Right.
It can't happen.
Yes, you are right. But if that third circle is to capture surfer flight there, and
Right.
you're saying that the minimum over there is 6,000.
So
why do you want 4,000?
because what happens if I put a 6,000 foot ring here and I don't accommodate the fact that the airplane's going to continue descending, it'll descend below the Class Bravo airspace. So if I keep them at 6, now we have to interrupt the vertical navigation and we'll lose the benefit of the continuous descent. There is no mechanism to have a slanting controlled airspace.
Yes.
So it's got to be done in blocks, and that's why we do
It is
that.
possible that there might be room, and this is why I keep asking you to submit a comment. There might be room to adjust that southern boundary of the 4,000 foot, that little jut out that you're concerned about. There might be room to inch that up a little bit. So that's what, put the comment, we have to capture the OPD, but there may be a little budget, we won't know until we look at it, but that's what your comment would give us to do.
If I can add to this, also airspace complexity comes into a point. You've heard the users out here saying, expressing a little concern about navigating around this. We could put a 6,000 foot right here, and then a 5,000, then a 4,000, and a 3,500, and things like that. It'd be highly complex airspace. And it's simply not necessary. Again, they're gonna cross here at or above 6,000 feet. Depending on the winds, it could be 7,000 or 8,000 feet. And it continuing as a descent, just because they cross this line right here at 6,000 to 4,000, the airplane won't be at 4,000 feet. Figure a 290-foot per nautical mile descent. And that math is pretty easy to figure out.
Right, are you saying that that is confirmed that the server, the existing server will not be lower or changing up?
No.
No, not, okay.
Right now, we're artificially interrupting the current server and creating more. Yes, ma'am?
I understand that it's complex, but when I looked at the graphs for many of the other airports, especially in major cities that had heavily populated areas, this is one of the most populated areas in the Bay Area. And many of those have that 5,000. I'm not suggesting you have 4,500, 5,500, you know, endlessly complicated. But many of them have that 5,000 block. And that makes sense to me over this heavily
Okay, so
populated area.
I would encourage everybody in this room to go look at the San Diego Class B airspace. It is very segmented, it is very chunked up, I have no idea what the history of it is. It may be for that very reason. I find it highly complex, and I would find it a bear to navigate around. And I'm looking at the airspace users nodding their head up and down, so.
Well, I guess I would like to hear from some of the airspace users whether if there's a 6,000 block, a 5,000 block, and then a 4,000 block over the bay, is that really that complicated?
Yes, every extra block is more complication,
While
more
I'm
difficulty.
I'm looking for those blocks while I'm trying not to hit the mountain and not impacting terrain as much.
There are not a lot of mountains in Sunnyvale, but just.
Yeah, there are actually. It doesn't take very long in a plane.
So I will point out that one of the airspace users out here did point the fact that the ridgeline out here, we're forcing the VFR flyer closer to the terrain out here, and we recognize that. So we are going back to take a look at this anyway. Because we do not want to be in a spot where we're pushing airplanes down into terrain. We're not going to go there.
Phoenix has.
Yeah, Phoenix has an issue, let's not talk about Phoenix.
Wait, I have just one more question, sorry. Not done yet. Yeah, that is a very similar one. So those red lines represent whatever I observed occurring after SSO flight. So my question is,
Maybe can you get closer to the microphone, please?
so will they become possible new SFO flights in the
So I will
future?
tell you, we don't have, this track right here at 4,000 feet, only those operations out there would be turboprops, which we don't have a whole lot of anymore, landing San Francisco, and San Francisco go-arounds.
Mhm.
This is a very exaggerated track. While I'm not saying it never ever happened, this is very unusual. Normally what you would see is the airplane come down like here, be vectored off this way, back around here, and then turn on. To go out here over the top of San Jose. and
No,
then-
that is Sunnyvale.
Okay, well, excuse me, the South Bay, I'm talking San Jose Airport. But, you know, this would be a huge, this flight track right here would be a huge impact to San Jose traffic. While I'm not saying it never ever happened, this is highly unusual, and this is not normal by any stretch of the imagination.
So that means those just the vector, the flight, it would not likely to become permanent in the future.
Oh, no, nor would you want it to be.
Okay, that's-
I mean, I can't think of the time I've seen an airplane enter the airspace over here. Again, I'm not saying never ever, but I can't think of when. And then to vector an airplane this close to the San Jose airport, that have to stop San Jose departures, that creates its own problem.
No, but the San Jose departure goes to the east, right?
Well, but they
It's
still depart to the north, and they still depart, and they still have to make that turn and do the physics of a turn. They're 200 knots. It's at a 25-degree bank angle. That's a wide turn. Air traffic's obligated to provide 3 miles of lateral separation.
So that you have space B, so San Jose will not get into your space.
Oh, no, San Jose, again, San Jose traffic while it does go through San Francisco Class B airspace, we don't consider it as part of the probable airspace. But departures, we're trying to get, are now currently restricted to 200 knots out here, and we're trying to relieve that for the San Jose departures. We want them to go fast and climb high and go away, right?
Yeah, so our concern is that we do not need more vectoring SFO.
And I've said this to everybody. We're not gonna vector airplanes where we don't vector airplanes now.
But you may accidentally
And,
make it.
okay, so emergencies, all bets are off, okay? Unusual weather events, all bets are off, but on a routine operation, and we don't like emergencies, and we don't like unusual weather events, so we try to avoid those kind of things. Yes, ma'am?
Question regarding the rapid descents. When the plane comes down rapidly, the proposed